Alright, so if I want to calculate the ratio of my surface areas, I take my scale factor and I'm going to square it. So the ratio of surface area will equal 4 to 5 squared. And when I do that, that means I'm doing 4 squared to 5 squared, which would be a 16 to 25 ratio. Now when I do it to 7/12, I follow the same idea. So the ratio of my surface area would equal the ratio of the 7/12 squared. So that's 7 squared to 12 squared, which would be a 49 to 144 ratio of the surface areas. Now the next problem asks us to look at the idea of that it tells me that AD is 1/4 of the way to dB. So I know that in essence, if I think about this, I have similar triangles. I know that if I wanted to, I could say here's A, D, E, that this is 1/4, and I'm going to make these not actually to scale, but this would be like a 1/4 to 1, which means that this would be 1/4 to 1, and this would be 1/4 to 1. So if I want to think about, well, what does that mean about the ratio of their areas, I know that the ratio of the areas, as we just said a minute ago, would be equal to that 1/4 quantity squared, because it's both the length and the width. If you think about the two, my two aspects that create my area that are being changed by this similarity. So I would say that that is 1 squared to 4 squared, which would be 1/16. What that means is if I've created 16 of these little triangles the size of ADE, they would fit inside the larger triangle of ABC. So that's the difference between scale factor of a side versus scale factor of the area. Now let's look at the similar pyramid problem. So before we talked about the idea of Great Pyramid of Giza, which has a square base of 756 feet and approximate surface area that doesn't include that base of 900,000 square feet. And we want to make a model that's 1 foot to 200 foot ratio. So we want to know what's the length of each side of the square base. So here I'm dealing with the length of it. So my scale factor is a length ratio. So if I go 1 to 200, I know that I can go x to 756. And I know that's in feet. So I know this is 1 foot and this is 200 feet. So I get 200 feet times x equals 756 square feet. So when I divide both sides by 200 feet, I know that my feet cancels one of those squared, and then 756 divided by 200 is approximately 3 7/8 feet. So about 3 3/4 feet, and 3/4 of a foot is about 9 inches. So we're looking at about 3 feet 9 inches for each side of this base. Now the second question that's asked about the square feet. Now here what I have to remember is that when I'm looking at square feet, that the ratio, this was of the lengths, so I have to remember that that's squared, and that would equal the 900,000 square feet. So if I do this, I would have 1, and then 200 squared will give me 40,000. Oh, one too many zeros there. Erase here. If I think about it, this is technically square feet, and this is square feet. So I get 40,000 square feet times x equals 900,000, and this would be feet to the fourth. So then when I divide by the 40,000 square feet on both sides, I'll see that my units go back to the squared, so that x would be approximately 22.5 square feet. So I would be doing 22.5 square feet of cardboard would be needed to make my model pyramid.